Welcome back everyone to theCUBE here in Palo Alto. I'm John Furrier, host of theCUBE with Dave Vellante. We're here for a 3-day series on robotics and AI infrastructure leaders. We're chronicling all the action going on at the infrastructure and also at the data layer to enable this next wave of generative AI. We're seeing robotics, we're seeing agents, a lot of disruption in a very positive way, a lot of enablement. We've got a great panel of experts here. Vijay is the Vice President of Marketing and Strategy at Broadcom. Vijay, great to see you again. Thanks for coming on.
Thank you, John. Thank you, Dave, for having me here.
Harminder is the CFO of Blaize AI. Thanks for coming on, appreciate it.
Thank you.
And we have Gopal's the SVP of Engineering Operations at SiMa.ai. Great to have you on, good to see you.
Thank you so much. And
guys, you guys, it's a tough panel here because you got a lot of expertise, and one of the biggest themes that everyone's talking about is when are we going to get through hit the end zone, if you will, for the AI infrastructure, fully unleash the agents. And so a lot of conversations are around, how do I build a data center? Who do I, if you're in an enterprise, who do I talk to? How do I create the future of work? How do I build robots that are going to have the intelligence? So it's basically a distributed computing network we're living in, it's hybrid. And the top conversation is the speed there? Is it reliable? Is it safe? And can the packets move fast, low latency? So this is the top conversation. So I'd like you guys to introduce yourself, talk about what you're working on and what you're doing with infrastructure. Vijay, we'll start with you.
Thank you, John. Vijay Nagarajan and, from Broadcom. As you all know, Broadcom does everything, I guess, from the cloud all the way to the edge of the network. So we take pride in connecting everything. Specific to this panel on the edge, our focus on the edge has always been around, again, connectivity and also the edge platform, which is our broadband platform. So we believe that there is an edge play when it comes to your home, where you have broadband gateways that are serviced by the carriers and service providers across the globe. If that has an ML engine and it can actually service LLMs and can support use cases, that's a great way to offer new AI services to
and the networking consumer. Chips, you guys just announced Tomahawk 6, which is really hitting the performance there. Right. So the chips, thanks for what you do, appreciate.
Thank you. So that's part of it. So there's the infrastructure chips, including our networking with the Ethernet side, but also I think the edge is a very important play.
Yeah. Robotics a big edge. Harminder, what are you working on? What's cool there? You're the CFO, you look at the numbers, you see the business growth. What's going on in your world?
So I'm standing in for my CEO as he's traveling. I want to start with, the company was founded by 4 very smart engineers that worked on the GPUs at Intel 20 plus years ago. And what they've developed is, you alluded to it, a purpose-built piece of silicon. And in our case, it's programmable. So when you look at what's happening at the edge and what the requirements of the edge are, which is low power, low latency, high efficiency, and if you think about the autonomous driving as a use case, the demands for that are very specific. And we feel that bringing that, automotive is, towards the end of the decade for us. But in the near term, we've got use cases that are in smart cities, smart retail, industrial automation, defense. And we think that the Blaize architecture, which is hardware, software, allows this data that's being generated, 1 million times more data at the edge, to actually be harnessed and people to take advantage of it.
And the multimodal is super hot,
exactly.
Computer vision.
Yes.
Gopal, you guys are doing a lot of work. Share what you're doing and what you're working on, what's cool.
thank you. First of all, thank you for having me on this panel. It's great to be here with esteemed industry leaders. So we are a 6-year-old Silicon Valley startup company, and we are focused on what we call an embedded edge market. And as our CEO says, people actually live at the edge. And for us, robotics as well as Gen AI are the key areas that we are actually working on. Our 2nd generation chip, which is in the market, which is this chip here. Okay, this is built using TSMC 6 nanometer process node technology, and this is fully software compatible with our 1st generation product that was mainly CNNs. Okay, so this one is multimodal, so we can support voice, text, video processing, natural language processing, all on a single piece of silicon. And the applications that we go into cover 12 different embedded edge verticals: security surveillance, aerospace and defense, agriculture technology, medical, and so on and so on.
And that's in the devices, the edge device, that chip?
Correct. So what we built here in this chip is what we call a system on a chip. So this is machine learning system on a chip architecture. So if you look at the applications that are at the edge, they're not just about the ML models, right? So in the cloud, you're mostly looking at models and accelerating models. At the edge, you're actually running end-to-end applications. So we actually take the images or voice or text coming from a sensor, whether it is a camera or a speaker or a radar or a LiDAR, and we process it all the way to actually displaying it on the screen or providing a response back to you. Yeah. So you can actually run your end-to-end applications. And our big differentiation is really, it's very purpose-built. And at the edge, as you rightly pointed out, power is of paramount importance. Robots, for example, are battery-powered, and you don't want to keep charging them. So you want to run them for as long as possible. Drones, for example, need to be running as long as possible. So power is very important. Performance is very important. So we provide significantly higher performance, 8 cameras, 16 cameras. So for example, in a security surveillance retail application, we are able to support 30, 40, 80 cameras and able to detect different kinds of things with our product.
So low power in real time, essentially. And you all partner together? You cooperate? You compete in some places?
Well, I know we use one of his parts in our quad PCI, and I had a chat with him last week.
There's some deals on theCUBE, all right.
Well,
DJ, how's the schedule going out?
It's an interesting market, right?
But we often, like the SiMa, we have a similar approach, similar kind of use cases that we're probably solving them in a slightly different way. Our belief is that an ecosystem of ISV partners is crucial because for us to scale, we need to have people that have applications that may be running on a GPU and maybe perhaps not running as efficiently as it could. That's how we scale.
Yeah, we're going to talk about the ecosystem because there's the heterogeneous environment we all know is where it's going. Yeah. There is some homogeneous kind of use cases and self-contained stuff we're seeing out there, so I want to put a pin in that. But I want to come back to some of the commentary you guys on the intro. I love the edge because remember the intelligent edge, Dave? It's like, man, the intelligent, that was like 7 years ago, the intelligence can be hot. It was basically, if you got power and connectivity, you could do something.
Right.
Okay, so that's
Absolutely.
it. Now you're talking about data acquisition, using data, applications at the edge, but you're also getting data in. So if you got these devices, you need the connectivity and the power, and everything's bounded by power on the compute side and the devices. So now you have data coming in, but you're trying to use data for Gen AI, and then you got fresh data coming in that has to be processed on the device. So there's going to be a huge demand, we think, of high performance, small form factor devices, because when you're ingesting computer vision, you don't send it across the network. Maybe you will, but that's just more latency.
So I have a perfect example for that. We're working now with smart city customers. And so if you look at smart city, you've got cameras that are on lampposts. So our chip is industrial grade, so it can already withstand temperatures and vibrations. And you can hook up 5, 6 cameras to one of those edge boxes that's sitting on a lamppost. Now you get 100 or 1,000 of those coming into a server. Mm-hmm. The use cases are really good because you're saving money for a customer by the cameras observing no activity happening at night, and you lower the lights, and that's a saving. As soon as anything's detected, the lights go up, the frame rate goes up, and you do object detection, you send an alert to whoever needs to go. All of that is happening at the edge box.
You see that all the time in smart city. You go, whoa, what just happened?
Right.
And that's just
so,
what happened,
but this is now, we are working with customers in South America and in Asia Pac regions on those kind of, and that's been our focus. One of the things that Blaize technology allows you to do is a lot of things for a lot of people at the edge. And so our focus right now is just smart city, where we know we're making dumb cameras smarter, and then some of the defense applications. We talked about drones, for example. I mean, sadly, the Ukraine war has just told us, how you can disable a drone, but also how a drone can be more intelligent because it's got onboard compute.
How are people, go ahead, Vijay.
Now, John, you talked about ecosystem, right? And this, and you also asked if we were competing or collaborating. I think the right word I'd like to use is complementary. I think chipset vendors and the types of devices that we work with is very, very complementary. Case in point being what Harminder mentioned. So you have their, say, true edge devices right at the edge. And the question comes up on, where does the processing even happen, right? Does it happen right at the edge? Do you have to go back to, say, one level in to another device? So I think having different categories of devices that are actually interacting with each other through connectivity is extremely crucial.
Connectivity is important in the orchestration. In a way, an operating system has to be built. So to your point about ecosystem, we used to say it's in the database world, and there's no one database to rule the world. You have to have, now you see multiple databases, every application has a database, but now you have a horizontal plane managing it. When you look at networking, how do you guys see the architecture? Because we haven't even thrown in with smart cities is things like sovereignty.
Yeah.
I mean, you got to design the intelligence that may not, has to be at the edge, but also in a data center somewhere,
Right.
Managing policies. I'm oversimplifying it, but like I say, if I'm in France and I want to keep that traffic in the network, that's a sovereignty issue. It's a sovereign cloud challenge, or on country.
Yeah, so I think typically all these devices have to be provisioned, managed, upgraded, etc. Right? So if you think about for the ML at the edge, there is MLOps, which is essentially your life cycle for your ML application. So the edge applications get smarter. For example, you detect certain things in the smart city use case that Harminder talked about. You may be detecting certain types of people, or certain types of threats, or certain types of events, right? So how do you keep updating those, right? So for that, there is a process which actually collects all this information, sends it to the cloud, and continuously runs a process in the cloud to find out whether anything new needs to be added. And when something new needs to be added, that model gets trained, and then it gets deployed back to the device. Okay, so networking becomes very, very important. Connectivity becomes very, very important. Cloud to edge continuum becomes very, very important, right? So in that sense, the connectivity that is provided is very, very useful. And it's not just about that, right? So if you think about, for example, Gen AI, how do you make these models smarter, right? If you want a model to be customized for your application, for example, if you're working with a car manufacturer and you want to take a Llama model and you want to make that model specific to that car manufacturer, you can actually feed a car user manual, okay? So the process is called RAG, okay? Retrieval Augmented Generation. So what it does is it reads that document and trains that model with that new information. Now, how do you do that? This thing happens in the cloud, and the data then gets sent to the edge device, and the edge device becomes smarter. So this is a way to keep your edge device up to date, keep your edge device current, and also manage a bunch of edge devices that are actually deployed across your assembly line, across your smart city, smart factory, smart transportation kind of environment.
Typically, we would think of edge applications from a persistent standpoint, as a lot of the data is ephemeral. You only send certain data back to the cloud. Take automotive, and a deer runs in front of the Tesla. Oh, that's an event, we'll send it back. Video maybe is different, but has machine learning and AI changed that, where that in between, that intermittent data is more valuable, or is it still, you're only persisting, a small portion of the data?
So the challenge with the benefit of the edge is that, so if you want to send all that data back to the cloud, then you have latency problems, right?
Latency,
so
it's expensive.
It's very expensive, and you may not even have the connectivity, right? So we are working with customers. For example, these people are, so the train track inspection, for example, right? So they use drones now, and they inspect the train tracks, and they send that information back to the data center, and where people are manually looking over those to find out whether there are any problems, or they feed the videos to data center servers. This whole process takes a long time. What if you put a device on the train itself, and while one train is running, it actually detects these things, or the drone itself detects some cracks in the track, and then informs the data center, and then you can actually control. So what you are sending back is not the actual video, you are sending just the event. Okay, so the amount of data that goes back is actually very, very simple. So we have an application where our product is being used today. So they have a system where along high-speed freight tracks, this is in India, they actually have deployed cameras, and they actually look at a freight train as it goes by, and they look at, is the wheels on the train flat? Is the door on the wagon open? So this information is analyzed, and the event is sent to the control center, which is at one of these train junctions, and the operator can now make the decision, should I slow down the train? Should I stop the train and fix the problem, right? So instead of sending the entire video back and having manual processing or cloud processing, which is very expensive and is latency prone, what you are doing is you're just sending that one event.
Yeah, and we're seeing robots climb bridges and looking for anomalies, and so you're just sending back that event.
Exactly.
But you still need good networking.
Of course.
And you want it to be high speed, low latency, and low cost.
You hit it. And then there's also, from an edge perspective or an edge to cloud perspective, you're talking about privacy as well, right? So, so you have all these vectors that determine where the data gets processed, where it is getting computed. You know, as Gopal said, is it at the edge, is it with the robots, or is it at a localized data center, not necessarily all the way back to the cloud? Is it a localized data center, or in the case of a residence, is it at the carrier gateway? So you could have a situation where you know, you could have smart cameras that are detecting events, or you could have cameras that simply transfer the video back to the gateway, and the gateway does the processing and transfers the event back to the cloud. So I think it's use case dependent, and it's dependent on these variables that you just stated, which is latency, speed, performance, cost, and then privacy and security as well. And from a connectivity or a networking perspective, to that end, you know, we have to look at everything, you know, starting right from the edge, the devices that Gopal and Harminder talk about, you know, which would require, say, wireless connectivity back to a localized device, local device, a local data center, and then back to the cloud through wired networking. So the network architecture has to contemplate, you know, every event or everything starting from the edge all the way to the cloud, includes wireless, wired, and all these KPIs.
Yeah, I mean, Broadcom, you guys are building the chips. They're smaller, they're faster, they're more energy efficient, reducing the hops on the scale up. This guy got the scale out. When you look at robotics as well as the edge, you're starting to see use cases in manufacturing, retail, automotive. They're everywhere, where there's a robotic element, even humanoids. We're seeing that work being done, covered that here. You're seeing this notion of self-contained unit.
Right.
That needs open standards, but it needs to be highly customized for the performance of the thing, whether it's a robot or a manufacturing line. How do you guys look at that? Because there's been debates right now in the industry, not debates, but been conjecture, I would say, between homogeneous systems that just work.
OSP.
Okay.
OSP.
And then you got open systems, OSP, that's
remembered
a
it this
Broadcom
time,
thing. Dave's memorized it. Charlie quizzed Dave on the FYI. Charlie Kawaz, if you're
Dave's
watching.
never gonna
Dave
forget
is,
that.
he's got it memorized. But also, if you don't have an ecosystem, you can't scale because there's now interoperability challenges. So there's a trade-off, this discussion, when do you harden top things?
Yeah.
When do you keep it open, or it should be open obviously all the time, but.
So a couple of points came up on the previous conversation which are really important. Privacy, and you know, how do you keep your data? So this air gap, the concept of air gap solutions, you don't actually necessarily have to send, you're collecting a lot of data, you're processing a lot of it, as Gopal said, at the edge, because it's important. That's where you need the result, right? And then maybe for training purposes and other reasons, you know, the video gets uploaded to the center. But it's still your data. It doesn't go out into anybody else if you've got facial recognition. You mentioned France or Europe generally, right? But coming to the, you know, the robotic type of thing. So we're working, we happen to be, it's accidental. Samsung was our foundry out of Austin. So we tick the box of made in America. And therefore, a lot of the defense type of applications for us are open to us. So the box that we have, there's a carrier board which has AI running on it, which can sit on a drone, and it makes the drone extremely intelligent. Versatile. We've got use cases similar with oil pipeline type of inspection, that a lot of the work can be done there and then, and what you're just sending is, you know, mile 644 is where there might be a problem, as opposed to the video coming back and somebody processing it, and then 2 days later deciding, to go to mile 44. So those are the things that we find that customers are valuing, the ability to just take those decisions there and then.
That's a solution, though. That's a solution built upon components that are open.
Correct.
So it's not so much that's a heterogeneous chip or whatever.
Yeah, exactly.
So to answer your question specifically with regards to robotics, right? Open standards are very important, right? You cannot have a complete vertical solution for this market, and that's how even the industry leaders are proceeding, right? So NVIDIA has a framework called ISAC. Okay, I don't know exactly what it stands for, but it's a framework, right? A lot of these robots are built on what is called ROS, Robotic Operating System, okay? And the latest version of ROS is ROS 2. Intrinsic, we work with them. They actually acquired ROS, and what they're trying to do is to create a platform which is a software platform for industrial robots, right? We're working with multiple customers. We recently announced AMR, Autonomous Mobile Robot Design Win. So what these guys do is they build a common platform that goes into these AMRs, and the ROS has multiple components. One component is SLAM, okay? So what SLAM allows the robots to do is to move, okay? And there are different types of SLAM.
And that's open source.
It's open source. It's completely open source. So it runs on compute, for example, today, right? So typically all these run on x86 compute. Now, you can speed it up by actually using ML accelerator, okay? So we're doing that. And there are different types of SLAM, okay? Cartographer SLAM, visual SLAM, all are open source, right? Then on top of that, all these ML models, applications, for example, pose estimation, okay? Or a object detection or a tracking, all these different applications which a robot needs to have are all can be actually run on SLAM and on ROS, for example. So what SLAM plus ROS gives you this framework, which is an open source framework. SLAM gives you the control and movement, and then the applications which are built using ML give you the ability to run different applications. So that's really what is being developed for robotics. I really like that because this levels the playing field. Our customers like it because it doesn't lock them into a particular...
It increases innovation too. The entrepreneurial world will jump on this.
Absolutely.
So you have more technical advances.
Absolutely.
Interoperability. Vijay, I know this is something close to your heart on open systems. We've had many conversations around open systems, the benefits of it. You guys are making the chips smaller, but the density is still a challenge because you can make the chips smaller, but there's more stuff on stuff, right? So you got more density, but still chips. Why is open important to you guys?
For almost the same reasons that Gopal stated, right? So you want this to be a place where there is a vibrant ecosystem, right? Open's where you can get a scalable ecosystem where you need people that are talking to each other, devices that are talking to each other. For me personally, if I've learned anything from being in Wi-Fi for about 20, 25 years, it's that you need open standards-based technologies that will allow a vibrant ecosystem to thrive. We need interoperability. We need certification around devices that are interoperating with each other with a common protocol. And if you have that, then I think everybody wins. A closed walled garden doesn't. But with an open approach, everybody in the ecosystem wins.
Well, I think we've seen that open drives opportunity.
And innovation.
And innovation.
And
innovation.
And TAM.
Yes.
Yes.
So you're today participating in, let's call it roughly a $4 trillion TAM. And by all estimates, that's going to, let's call it 3x, 4x, maybe even 5x. So I have two sort of questions. One, maybe not so controversial. The other one you might not want to answer, but I'm asking it anyway. How are we feeling about full self-driving? Harminder, you mentioned it's kind of end of the decade for you guys. What are your thoughts on that?
So if by full you mean level 5?
Yep.
I mean, from what I hear, the experts talk about, there's your camera technology has to improve. There are all sorts of other things that need to improve. I certainly think L3 plus L4 is possible. We've been working with Denso, has been an investor and a customer of ours for 7 years. And actually that relationship was super important for us because they validated the architecture that we built. because the vehicle is the most discerning, object which is moving that needs to make decisions. When you get to, we did work with another German OEM around L4 type of applications, more a chiplet type approach. So we definitely see that if you are not Tesla and you don't have your own chip and you want to have an alternative to Mobileye or another GPU-based sort of solution, then Blaize is a very, very important partner for you. And we expect to accelerate the work with some of these OEMs and tier ones. And when I say that revenue for us comes at the end of the decade, it takes 5-6 years for some of these systems to get into place.
So part of the catalyst for Tesla doing its own design was not only did it want to customize the NPU, but there was issues with Mobileye and who controls the data. I presume that you're open about that.
And here's what all the OEMs and tier ones that we worked with said to us: please go sell your chip to every other OEM. Mm-hmm. And why would they say that? Because the differentiation is not at the software layer. Mm-hmm. It's what I heard a Ford CEO guy talk about a year ago, but there's 150 ECU microprocessors. Yeah. Okay, that's one problem, but they're from maybe half a dozen manufacturers. Think of all the different software challenges that they have. So talking about open standards is really important, because based on a Blaize architecture, which is programmable, so our SDK is open. We have a low-code, no-code AI Studio platform for those people that can't code, that they can deploy AI. So when you put all of this together, so for us, the autonomous opportunity is huge, and that's a hockey stick that happens towards the end of the decade for us.
Second question, you mentioned Samsung, you guys TSM, 6 nanometer, you guys, of course, rely on TSM, and you even have your own foundry, I think, for thin film, because of some of the constraints in the marketplace. So how are we feeling about foundry capacity? There's obviously geopolitical tensions. How important is it to have foundry based in the United States?
Maybe I'll go. So we've worked with both TSMC and Samsung. Obviously for defense, having something in the US is important. We think we don't necessarily need to be at the cutting edge processor node all the time, just because our architecture uses those TOPS in a much more efficient way. Mm-hmm. So it's, all the foundries that are coming up in Arizona, we would be customers for those.
Not cutting edge, but near cutting edge.
Near cutting edge. We don't have to be at 2 nanometer, for example.
You guys do.
We guys do, and I mean, like, in some of our 3 nanometers, 2 nanometers, things that we could look at. See, from our vantage, again, I go back to this thing that a vibrant ecosystem is important, and that goes to supply chain as well. From our vantage, yes, we do a lot of our merchant silicon with TSMC, but at the same time, we proudly manufacture a lot of our, say, RF filters here in the US in our fabs. So it's something that we believe in overall, that the vibrant ecosystem needs to exist, and supply chain is no exception.
Mm-hmm. Yeah, I agree. I think the challenge, I think, for the US in general, speaking about TSMC, and this is public information, that the US cost is higher relative to the cost they have in Taiwan, but they are doing it here as well. So working with someone like TSMC gives us options. If you really want to manufacture in the US, you can in the Arizona fab, or you can go to Taiwan. And as Harminder said, we are not at the bleeding edge. By the way, as a small company, we can't even afford a 5 or a 3 nanometer. Okay, so I am at 6 nanometer, and 6 nanometer is actually decent enough for us for the product we deliver. Our architecture is all digital, and it is quite efficient from a power and performance standpoint. So that technology can be available here as well. So in that sense, having an ecosystem is important, having a choice is important. I'm very happy that Samsung has a lot of US presence. Intel is building fabs here, and the government is investing, because having options, having an ecosystem for companies like fabless semiconductors like ourselves is very, very critical.
But could you go to Global Foundry or no? Because they're not
I have used
enough.
Global in the past, right? So at Cavium, my previous company, we were a big customer of Global. Only reason why we are not using Global is that below 10 nanometer, they're not as good, okay? Right. In terms of, they have stayed at a higher technology node. And of course, TSMC is
But the
world
yields
class.
aren't there.
Yields and things like that.
I've been outspoken on this issue. I'm not comfortable with where we are in terms of the foundries in the US. I mean, I was hoping that Intel would actually divest of the foundry, but that's not going to happen. And so my feeling is they're going to become kind of maybe a little bit more advanced than Global Foundry, but not to the TSM level. And TSM, unless they bring expertise here, I see that as problematic, is what we're seeing now with the tensions for things like rare earth metals, and there's some issues that I think are maybe not blind spots, but risks that need to be
I agree. I think, but then here is one data point for you, right? Other than the high-end processors or the GPUs, vast majority of semiconductors are at higher node, right? So to that extent, having capacity and ability to build those in the US is very, very critical, right? But do you need a 2 nanometer process node in the US? Maybe you do for certain products, but not for everything.
Okay, so I agree with that. So that level of comfort exists.
Correct.
That
so
US
the market's
manufacturers be able to take care of.
stable there because you have use cases that require massive, smaller, bigger throughput. I guess the question here during this event we're having is robotics has a surge of, I won't say democratization, it's kind of not the right word, but like the builders doing robotics and edge is getting very device and specific, like robotics is booming. There's a huge surge, and then infrastructure leaders have to now serve this different edge or more robust edge, whatever you want to call it. So the question is, what's the architectural design principles that people should be thinking about? Entrepreneurs, partners, we believe the ecosystem is going to be booming because once the distributed computing is connected with the power, with the batteries and some of the energy stuff going on, there'll be a surge of innovation that'll be built, enabled by you guys. So like, what's the playbook?
This is a very interesting question. So I'll tell you this, right? So the entire world is changing very, very rapidly, right? So all of us are familiar with DeepSeek, right? So when people actually are very creative, world over. It's not specific to a country or whatever. They're very creative. They get the best out of the technology they have. Okay, so I'll give you one example, right? So for our next generation product, we're looking at what are the requirements for something like a humanoid robot, and my architect came back and told me, hey, I need to have this 400 tops, I need this requirement because the large language models are exploding. This I'm talking 6 months ago. So I said, okay, let's don't think about what is happening today. Think about what is going to happen in 5 years from now, 3 years from now, 4 years from now, because that's when the chips come out. What is happening is that to make the robots work, to your point, the power is very important, the cost is very important, the area is very important. So essentially, we have gone from large language models to small language models. The VLMs and VLAs are actually getting more and more efficient, and they are able to do things with less parameters. So what we are finding is that, I'll give you our own example. We are finding that 6 nanometer technology, we can actually address humanoid robots. It requires software changes. It requires architectural changes that we need to do to our chip. But do I need to go to a 2 nanometer for that, right? So a combination of hardware and software becomes the solution. It's not just hardware alone. And one of the things we have done at SiMa all along is, to the point Harminder made as well, okay, don't worry about the tops, okay? So 400 tops doesn't mean anything. What is the metric you care about, okay? If you care about, let's say in a computer vision application, if you care about frames per second, can I give you the same frames per second with less tops, right? So a lot of the architectures that are out there are not very efficient, right? So if you look at a large language model today, they use only a very small percentage of the compute available to them. Now, how do I increase that percentage and how do I make my compute more effective? Okay, through software gives you the ability to actually not necessarily go and build these high-end, high-power, high-cost chips, but stay at a lower level, but solve the problem with software. And I'm very happy to see tremendous innovation happening in this field. Okay, so the physical intelligence model, the GROOT model, just so that we are running all those on these chips today.
Okay, so what you're saying is the constraints are critical to identify so that the software optimization, the creative DeepSeek moment, because basically kind of discovered it by accident.
Yes.
We know what the real story there is, that they didn't really do it for that reason. They were trying to get around their constraint, which I don't have the big GPUs, right? So, okay, so what's the position of the constraint? Is it compute, power? What should people be innovating around from a software perspective?
So I really love so Dinakar comes up, uses this analogy, and it's so simple. When DeepSeek came out, what it demonstrated was that you don't have to wake up the whole chip or the whole model. And his analogy is, hey, somebody says, what's 2 + 3? There's a math teacher on the model, there's a lawyer, it might be a dental hygienist, whoever. You've got all of these people, and suddenly a question comes in and you've woken up everybody. Think about the power that takes, right? And so what DeepSeek showed was mixture of experts. Hey, this is a math question.
Ask the second grader.
Right. Now, here's where the Blaize technology is really relevant, because we're able to run multiple things on our chip at the same time, which need not be related to each other. Right? And therefore, if you were to run a DeepSeek type, and the point you're making is very relevant, all these models are becoming smaller, and the accuracy is not being, is still pretty high. Yeah. So running those kind of models, we think on the common architecture that's going to be throughout our roadmap, is going to enable these language models to be very efficiently run and with very low power, because you're not waking up the whole chip.
So you're basically saying, and I love that example of waking up only the math teacher or the sub or second grader, as Dave said, but really getting into the fact that in the old school infrastructure days, over-provisioning or over-building was a concept. Yes. You're essentially saying that you don't have to over-rotate
it becomes modular.
So this speaks to some of the things you guys have been doing with the chips. You can think about the data center not as, give me the big fat rack and here's all my megawatts for the math question. Yes. You don't need.
It's not so much the over-provisioning. I think it's the other way around right now with AI, because you have some constraints, and to what Gopal said, sort of look forward to what use cases we're trying to solve 3, 4, 5 years hence, and the landscape's going to be very different. The models are evolving continuously, becoming more and more effective. So we have to start looking at other parameters to go optimize on, and specifically focus on use cases. You talked about 400 TOPS. The types of use cases in our gateways are, say, demand less than 5 TOPS right now. So it's really a function of the use cases. It's not a one-size-fits-all, especially at the edge.
Exactly. And that, I think, is like you said, you rightly said, how do you actually get your product customized for the use cases? And going back to robotics is a very interesting use case. Okay, it's very complicated, super complicated, but at the same time, a robot is doing one thing at a time, right? And sometimes it may be doing a couple of things at a time. So how do you actually build a chip which is cost optimized, power optimized? Because if you basically throw the hammer at it and try to solve that problem with lots of hardware, you're not going to have power efficiency, you're not going to have the cost structure. And if you run very complicated, very large models, to the point Harminder was making, why? Right? Why do you want all those other things that are not required there? So things are becoming much more specialized. Things are becoming much more optimized. And the software innovations are really key here. And we see this every day. And to the other point that Harminder made as well, this open source ecosystem of these models allows companies like us to innovate, right? So, I mean, Meta opening up, a Llama and making it available was a phenomenal moment, right? It basically made Google come out and put Gemma out there, okay, and Gemini out there. And all these guys, right? I mean, DeepSeek happened. If DeepSeek would have never happened if there was no open source model, okay? So this drives innovation, and the beauty of this is that people are driven by constraints. And they say, okay, what do I need to do? I need this robot to be cost effective, right? So the humanoid industrial robots, $175,000, how many people can afford that? It needs to be $1,500. To make that $1,500, you cannot use a $500 chip in there. You need a $100 chip. That's your constraint. What can you get in $100?
Okay,
or a different business model.
There you go.
Right? So
I was
going
to ask, how far away are we from general purpose humanoid robots, and what does the price point have to be? You're saying it has to be under 5 figures.
Yeah.
How far away are we? from that?
We are quite far away.
Like
so,
a decade plus?
I don't think it is decade plus, but it is not 2 years either.
Maybe
5 years.
Okay, but perhaps this decade, but certainly into next decade.
Absolutely, absolutely. And these robots are actually getting to be, quite intelligent. We're building one, and we're actually using this device, and it's a humanoid robot that actually moves around, and it can actually do simple things like pick up an object, all that. We are actually going to build this with 4 of these chips, and it's an off-the-shelf thing that we plug these things in, using these carrier cards, which are built for NVIDIA. So this is a NVIDIA carrier card. So NVIDIA has a very broad ecosystem. They have created a really good ecosystem. People build these carrier cards, and these carrier cards then get plugged into various types of like industrial robots or factory automation equipment, etc. So what we built is we built a module. This is called a SOM module, system on a module, which is a which is RN NX form factor. So I can plug this into a carrier card built for NVIDIA. So what this allows us to do is to go into all those platforms which are already deployed in the field, in the market with this. So what we are trying to do is to actually take advantage of the ecosystem, that is already out there, and work with all these partners, and that actually allows us a good way to go into market. And back to your robotics problem, how do you build a cost-effective, power-efficient robot? And if I want a robot which is less than 5 figures, I need to do it on one of these chips, not 5 chips.
1,500, I'm in.
So, I mean, basically what you're getting at is mindset, because if you throw hardware at the problem, you're going to have a big fat drone, a big fat robot.
Exactly.
Versus, I've interviewed an entrepreneur on this show where he's like, actually, we're going smaller because his use case is for a small drone. So his now optimization, what he's designing around is form factor. So he's actually working backwards from his goal. And now engineering the solution from the constraint.
And talking about drones, we're working with one of the drone companies, and I mean, it's very sad, but the most popular thing they have going for them is the kamikaze drones, So they go one-time drones. They can't afford a very high-cost compute system, but then how do you do that? You need a smaller chip, you need a lower power chip, you need a power-efficient architecture, and basically, the innovation is all in software.
Well, we didn't have enough time to talk about the future of, say, work, for instance, is a topic that comes up a lot on the show because we love robots and love to get in the weeds on some of the infrastructure. But at the end of the day, the other edge is our life. So I guess the final question is, what's the future of society, work? Because now digital and physical are blending. So now my relationship with my work, my play, society, is face-to-face. We have a big party last night, and everyone goes online. We're doing the digital event here. We're blending. So what, do I walk into an office space, the AI knows what my desk looked like before someone else used it? So what's the future of play, work? Because it's got wireless, it's got AI, it's going to be some sort of edge stuff. Thoughts? We'll start with Vijay and we'll end it on the panel on this question.
It's a broad question, John, right?
Hey, go to town.
It touches everything. It touches everything from work to life, right? And as at Broadcom, as an employee at Broadcom, I see the blending happen sort of gradually and seamlessly. I think we have to increasingly incorporate AI into the scheme of things, and at some point in time, the workforce, the nature of the workforce is going to change to be more AI educated and to be able to complement what AI can do. So essentially, they got to learn new things and change, right? That's how I see that happen. But on the flip side, and I've talked to you guys about this in the past, at home, I see tremendous change in terms of how we function on a daily basis. I, for one, believe that the future generation is going to be very, very, AI first. So, I'm the first person to go enable my 12-year-old and 8-year-old.
He's a prompt engineer now.
They are. They absolutely are prompt engineers. So I think they are going to be an AI first world, and so that's the skill that we have to teach them. And so the case in point being, whether it's at work or at home, we have to facilitate the preparation, we have to facilitate the education, for them, for people to participate in that AI-first future. That's my view.
And build better chips too, will go faster.
Yeah.
Harminder, what's your take on the future of society, life, work?
Yeah, so at the risk of repeating, I'll just add a couple of points to what Vijay has said. I think privacy is really important, okay? So how we deal with that. Clearly, there are huge benefits still to be reaped from just deploying AI. If you think about ag tech, if you think about healthcare, but of course, then there is, yesterday one of the guests talked about, huge disruption too. And is it going to take 10 years to work through that disruption? Is it going to take a generation? We got to solve those kind of problems. But the point is, we know it's here, and it's up to the innovation will help us work through it, I think.
Couple, close us out.
Yeah, so I think if you look at the waves of technology that has come about over the last 50 years, every wave has made us more efficient, more productive, right? So what I see AI doing is exactly the same. It is going to make our life more productive. It will take away a lot of the routine things that we are doing. Yes, there may be disruption in terms of really routine jobs now being done by AI. But at the same time, what people have done consistently is they have moved on to higher value jobs and higher value things and use the technology for our benefit. So I see us becoming more productive and basically doing a more interesting, more fulfilling things versus doing routine things, and the AI taking care of a lot of the routine work. And going back to the point Harminder made about privacy, okay, that's where edge is important. Edge is very important because if you send all your data to internet and to the cloud, you have no idea what is going to happen there. However, edge actually allows you to keep the data local, and what that allows you to do is to control who gets access to that data. Because in this new economy at Marvell, our CEO used to say, data is the new oil. Okay, so whoever has the most data wins, right? So that privacy can be addressed at the edge. So I see world changing in a better way, and in terms of and to the point Vijay made, it's actually very interesting, right? So we hire a lot of new school graduates now, and they are the ones who know AI like back of their hand. Okay, so they are the AI experts, right? So I learn a lot from them, and that is what is amazing, right? So they are actually becoming very good users of how to take AI into places where it hasn't been.
Yeah, I mean, this is the shift. It's a generational shift, how data centers are built, how networking is going to work, how utility will be extracted.
Yes.
Gentlemen, thank you so much. Really grateful for you coming on.
Thank you so much.
Thanks for coming on. We went a little bit over. Great mixture of experts here with theCUBE and the NYSE here in our Palo Alto studios of theCUBE. I'm John Furrier with Dave Vellante. Thanks for watching.